Okay, this will be Chapter 11, Helicopter Flying Handbook. This will be page 22 of 24, Abnormal Vibration. With the many rotating parts found in a helicopter, some vibration is inherent. A pilot needs to understand the cause and effect of helicopter vibrations because abnormal vibrations can cause premature component wear and may even result in structural failure. With experience, a pilot learns what vibrations are normal and those that are abnormal and can then decide whether to continue flight is safe or not. Helicopter vibrations are categorized into low, medium, or high frequency. So low frequency vibrations. Low frequency vibrations, 100 to 500 cycles per minute, usually originate from the main rotor system. The main rotor operational range, depending on the helicopter, is usually between 320 and 500 RPM. A rotor blade that is out of track or balance will cause a cycle to occur with every rotation. This vibration may be felt through the controls, the airframe, or a combination of both. The vibration may also have a definite direction or of push or thrust. It may be vertical, lateral, horizontal, or even a combination of these. Normally, the direction of the vibration can be determined by concentrating on the field of the vibration, which may push a pilot up and down, backwards and forwards, or in the case of a blade being out of phase from side to side. The direction of the vibration, whether it is felt in the controls or the airframe, is important information for the mechanic when he or she troubleshoots the source. Out of track or out of balance main rotor blades, damaged blades, worn bearings, dampers, out of adjustment, or worn parts are possible causes of low frequency vibrations. Medium and high frequency vibrations. Medium frequency vibrations, 1,000 to 2,000 cycles per minute, range between the low frequencies of the main rotor, 100 to 500 cycles per minute, and the high frequencies, 2,100 cycles per minute or higher, of the engine and tail rotor. Depending on the helicopter, medium frequency vibration sources may be engine and transmission cooling fans and accessories such as air conditioner compressors or driveline components. Medium frequency vibrations are felt through the entire airframe, and prolonged exposure to the vibrations will result in greater pilot fatigue. Most tail rotor vibrations fall into high frequency range, 2,100 cycles per minute or higher, and can be felt through the tail rotor pedals as long as there are no hydraulic actuators to dampen out the vibration. This vibration is felt by the pilot through his or her feet, which are usually put to sleep by the vibration. The tail rotor operates at approximately 6-to-1 ratio with the main rotor, meaning for every one rotation in the main rotor, the tail rotor rotates 6 times. A main rotor operating RPM of 350 means the tail rotor RPM would be 2,100 RPM. Any imbalance in tail rotor system is very harmful as it causes cracks to develop and rivets to work loose. Piston engines usually produce a normal amount of high frequency vibrations, which is aggravated by engine malfunctions, such as spark plug fouling, incorrect magneto timing, carburetor icing, or incorrect fuel-air mixture. Vibrations in turbine engines are often difficult to detect as the engines operate at a very high RPM. Turbine engine vibrations can be at 30,000 RPM internally, but common gearbox speeds are in the 1,000 to 3,000 RPM range for the output shaft. The vibrations in turbine engines may be short-lived as the engine disintegrates rapidly when damaged due to high RPM and forces present. Tracking and balance. Modern equipment used for tracking and balancing the main and tail rotor blades can also be used to detect other vibrations in the helicopter. These systems use accelerometers mounted around the helicopter to detect the direction, frequency, and intensity of the vibration. The built-in software can then analyze information, pinpoint the origin of vibration, and suggest the corrective action. The use of a system such as a health and usage monitoring system, a HUMS, provides the operator the ability to record engine and gearbox performance and provide rotor track and balance. The system has been around for over 30 years and is now becoming more affordable, more capable, and more commonplace in the rotorcraft industry. Whoa, so we'll hold off there. That was abnormal vibrations, low frequency, medium and high frequency, and tracking and balance. Ended up there on page 22 of 24 in chapter 11.